One of the most important concepts when analyzing CPU data in JProfiler is the thread status. The thread status selector is found at the top right corner of the call tree in the hotspots views. By default it is set to runnable, but when you open the drop-down list here you can see that there is a number of thread states, all states, runnable, waiting, blocking, and NetIO. So what do these mean? Just very quickly, all states is everything combined, meaning the total wall clock time that is spent in a method. Runnable is the time when your thread actually gets to do something, invoking methods. Waiting is essentially everything that ends up calling object wait. Blocking is when a thread is trying to acquire a monitor, a synchronized block, and is waiting for some other thread. And NetIO is a collection of methods that wait for data from a socket or trying to write data to a socket. So that's a set of special methods in the JRE that JProfiler knows about. Now, by default, it is set to runnable, and that's quite okay, because usually what you do is you're looking for performance bottlenecks, and then runnable is the right choice because you're looking for thread states where the thread actually does something rather than just sitting around and waiting for something. However, you do need to be aware of these other thread states and the thread status selector, because these other scenarios analyzing waiting and blocking or NetIO thread states are equally important. So you have to be able to switch the thread status selector when your requirements during the analysis change. So let's see how the thread status influences the display times. Now let's dig in a little here into the call tree. This is an example from the WebLogic server, Medrec. It's a JEE application. You can see the EJBs here, and when we drill down a little bit, eventually here we come to a JDBC call. This here is 33 microseconds of runnable time spent in this JDBC call here. Now that's only the time that is actually spent in the JDBC driver. Does not include the time that was spent in the database, just the runnable time in the JDBC driver. When we switch the thread status selector to all states, it shows us the total time, total wall clock time that it has taken to get the results. And that is 796 microseconds. Also, you notice that here for the top level node we now have 10,000 milliseconds rather than in the runnable state only 864 milliseconds. The difference is in the waiting state. So there's a lot of waiting going on here, very little actual running. And the 796 microseconds is the sum of the 33 microseconds in the runnable state plus the 763 microseconds in the NetIO state. Also, you've seen here that you can easily switch from one thread state to another without losing the context in your call tree, so it makes it really easy to analyze the same call stack in different thread states. In the hotspots view, the situation is really very much the same. The thread status selector here is linked to the thread status selector in the call tree view. So right now we stand at NetIO, although runnable is the default here as well. One important thing to note about the hotspot view is that for any hotspot type other than method, the thread status selector will switch to all states automatically. For example, here for the JDBC calls hotspot type, we now see the total wall clock times instead of just the runnable times. That really makes more sense for hotspot types other than method hotspot types. But it's important to be aware of this automatic change. When you switch back to method calls, your previous selection for the thread status will be activated. Another interesting observation is that your current thread status selection will be used when creating a call graph. For example, here we show the call graph for this hotspot, and all the displayed times here are now wall clock times for all thread states.